Hello students, welcome back. Today we will continue with the Ncert textual exercise of chapter number 3, that is motion in a straight line. Till our last video we had completed till question 3.12. So today, sorry, 3.11. Today we will solve question 3.12, 3.16 and 3.18. Okay, so let's begin with question 3.12. 3.12. A ball is dropped from a height of 90 meter on floor. At each collision with the floor, the ball loses one-tenth of its speed. Plot the speed time graph of its motion between t equal to 0 to 12 seconds. Now see it's speed time graph. Remember it's not velocity time, it's speed time. Okay. So see let's take that a ball is dropped from a height of 90 meter. Okay, so this is, okay, I will say that this is the floor. Okay, this is the floor. Okay, A, the ball was dropped from here, this position. Let's take B. Okay, so what will happen? As soon as the ball will strike on the floor, it will bounce back. Okay, so it will bounce back and it will also again rise. Now it will not rise to the same height, right? Okay, because as it is hit on the floor, it's given that its speed is reduced by 1/10. Clear? So it will not reach to the original height. So let's say that it is reaching up to this height. Okay, so I'm drawing that in another frame. Let the ball rise till here. Okay, this position it was B. Now let's say this is C. This is the maximum height. So at this height, its velocity will become 0 and then it will again fall down. Okay, so let me draw it in another frame. So from here, the ball will fall down, right? So let's take this motion is from C to D. Again, it's the same position B, but I'm taking different point. Okay, now again its speed reduced by 1/10. Again it will rise. Okay, so I'm drawing again another frame from D to, let's say now the height will be not up to C. Let's say this as E. Okay, so see in reality what happened? The ball, okay, it will fall from here. Okay, strike the floor, bounce back, again fall down, bounce back, again fall down, bounce back. Okay, so the motion is like this way. Finally the ball remains stationary. Okay, clear? But now say here what you have to do, you have to plot the graph of speed time of its motion between t equal to 0 to 12 seconds only. Clear? From 0 to 12 seconds only. So now see what I am taking. I am taking the initial velocity at a va, that will be v1. This will be equal to 0 because it is dropped. Okay, at position B, let's take here the velocity will be equal to v2. Okay, now when it again moves upward, at that time it loses its velocity by 1/10. So let's take this as v3. When it reaches to at this position, let's take v4, that will be also equal to 0. Okay, because this is the maximum height. Again it will fall down. Okay, when it will fall down, let that velocity be equal to v5. When it hit on the floor, again it moves up. Okay, so now let's find out the velocity v2. Okay, in every case what is the acceleration? In every case, or the acceleration, a is equal to 9.8 meter per second square, because this is the gravitational acceleration. Clear? So now first we will take the situation from A to B. Okay, A to B. Initial velocity v1 equal to 0. Clear? what is the height h, that is equal to, or let's take distance, I will take d. Okay, this is equal to 90 meter, right? This height is 90 meter. It's given. Clear? So 90 meter. Okay, we need to draw the graph of speed to time. So I need to find out v2 as well as the time. Clear? So I can use, what is the acceleration? A, that is equal to 9.8 meter per second square. Okay, so I need to use any kinematic equation. First I can need to find out the time. Okay, so v square minus v0 square equal to 280. I'm not having acceleration, I'm not having, but I'm not having final velocity. Here I will use d equal to v0t plus half at square. What is d? 90. v0 0 into t, it will be 0. Half, what is acceleration? 9.8, and it is in supporting. Okay, velocity is increasing, acceleration is 9.8, and t square. Okay, so t square will be equal to 90 into 2 divided by 9.8. Okay, so let us calculate. Okay, so it's 90 into 2 divided by 9.8, that is equal to 18.36, and that is equal to t square. Clear? So when I will take square root, it is 4.28. That implies t is equal to 4.28. Clear? The time here is 4.28. I got the time. Now V2. We will use the formula V equal to V0 plus AT. Means here V2 will be equal to V1 plus AT. So what is V1? It was 0, A 9.8 into T, that is 4.28. Clear? So let us calculate that. Okay, it's 9.8 into 4.28, that is equal to 41.94. So 41.94 meter per second square. Here I got V2 equal to 41.94 meter per second square. Clear? Okay, so time 4.28, V2 41.94. Clear? Now let's take from B to C. Okay, now see, I'm taking from here B to C. Okay, now what is the velocity? Now at B position, as soon as it strike on the floor, it reduces by 1/10. Clear? So V3 will be equal to, it was V2 minus 1/10, means 1/10 of V2. So what is V2? 41.94 minus 41.94 upon 10. Clear? So 41.94 upon 10, that will be equal to 4.194. So 41.94 minus 4.19, that is equal to 37.75. Right? So this will be 37.75 meter per second. Okay, what I did, 41.94, it was when it strike the floor. Now it reduces by 1/10, so minus 1/10 of 41.94. So 41.94 divided by 10, it is 4.19. So I subtracted it, I got 37.75. This is V3. What is the final velocity? It rises till height V3, V4. Clear? And remember, at maximum height, its velocity will be 0. Then only it will change its direction. So V4 is equal to 0. Clear? What is acceleration? 9.8. Okay, I have V4. Now I need to find out time. Clear? So what I will do, I will use the equation V equal to V0 plus AT. Okay, So in this case, I can use V4 final equal to V0 means V3 plus ET. Here, so what is V4? Final velocity is 0. V3 37.75 plus 9.8 into T. Okay, now see here velocity and acceleration. Okay, it is moving upward. You can say it is moving upward. So this is the direction of V. And acceleration is gravitational acceleration. Okay, so this is the direction of A. So I will take instead of plus 9.8 minus 9.8. Okay, both are in opposite direction. So 9.8t equal to 37.75. So t is equal to 37.75 upon 9.8. Clear? So let's calculate 37.75 divided by 9.8. This is equal to 3.85. 3.85 second. Time for time from B to C is 3.85 second. Clear? Okay. So from B to C the time is 3.85 second. Now let's take from C to D. C to D. Now remember, if you are throwing a ball in upward direction, okay, the time taken to reach the maximum height, okay, let's say you are throwing the ball from here, the time taken to reach the maximum height will be equal to the time taken to reach again back the floor. The time from B to C is 3.85, so the time from C to D will be also a 3.85. In this case, the time will be equal to 3.85 second. Clear? Okay, you are having final velocity V5. What is V5? V5 will be, now see, as soon as it will strike, okay, first we need to find out the V5. So V5 will be equal to initial velocity V4 plus AT. So what is V4? Okay, V4 was 0 plus acceleration 9.8 and time 3.85. Clear? So this will be equal to 3.85 will be, I am having this value into 9.8. This will be 37.75. This will be 37.75 meter per second. Here this will be V5. Okay, now see, we need to plot only from 0 to 12. Clear? So how much time? First time I was having is 4 point from A to B 4.28. 4.28 plus the second time 3.85 plus the third time 30 again 3.85. Okay, this is 11.98. That means it's round figure up to 12 second. Clear? So we will just note draw the graph till here. Okay. So now let's collect all these data once again. Okay. Okay. I will take time t and velocity v. At t equal to 0, okay, initial at position A, velocity was equal to 0. When it reached to B, how much time? 4.28. Okay. At that time, what was its velocity? 41.94. Okay. At, at the same position B, okay, V2 changes to V, reduces by 1/10. So from 4.94 at the same time, it reduces to 37.75. Clear? Now after from B to C, it takes time 3.85. Okay, so I will calculate it. 4.28 plus 3.85. So this is equal to 8.13. At 8.13. Here at 8.13, what is its velocity at position C when it strike at this position? From C, V equal to 0, and from here it falls back. Okay, its velocity at that position is, sorry, not velocity, speed is 0. So I'm writing here it's at position A, from A to B. Okay, B to C. Here now at C, again it will fall back from C to D. How much time it takes? It takes again 3.85. So 8.13 plus 3.85, that will be equal to 11.98. Okay, 11.98. What is its velocity? Sorry, speed at that time? 37.75. 37.75. Clear? And again it reduces by a tenth. Clear? Again, so V5, V6 will be equal to, I just forgot to calculate, V5 minus 1 by 10th of V5. So 37.75 minus 37.75 divided by 10, 3.77. Okay, so this will be equal to 37.75 minus 3.77. This is equal to 33.98. At this position, it changes from here to 33.98. Clear? So now let's draw the graph. Okay, I'm taking an y-axis velocity and at x-axis the time. Okay, so velocity, let's say it is starting from this point. It's let's say from 34. We will write down 34, 36, 38, 40, 42, 44. Okay, so at t equal to 0, velocity v is equal to 0. Time, I will write it down: 2, 4, 6, 8, 10, 12, 14. At t equal to 0, this is equal to 0 velocity. This is the point. At t equal to 4.28, means somewhere here, it's 41.94. Okay, so it will be like here. Let's plot this point here. Okay, slide greater than 4. Okay, and at the same time it gets dropped to 37.75. So 36, it will be 37, and here. Okay, then at 8.13 the velocity is uh, 0. So 8.13, that means it will be here somewhere. Clear? The velocity is 0. At 11.98 means near to 12, it will be 37.75. Okay, so I will write down here at the same point for the velocity. Okay, near to 37.75. Okay, then it will drop to 33.98. So between 34 and this, somewhat here. Okay, and after that, again it will drop to 0. So my graph will be in like this way. Here, this point is 0 time, 0 velocity. Okay, 0 time, 0 velocity. Here, this point is 4.28 second velocity, 41.94. Again, x same, 4.28, but velocity 37.75. Okay, from this point it goes to this 8.13 and velocity 0. Okay, from here it goes again to this point is 11.98 and the velocity 37.75. Again 11.98, the velocity 33.98, and then it will be decreasing. Okay, so this is the graph of velocity versus, or sorry, speed versus time. Okay, speed versus time from t equal to 0 to t equal to 12. Okay, so I'm just extending this graph, enlarging. Okay, this is the graph in enlarged view. Okay, now just note down the complete question. Okay, just note it down. Okay, now let's move ahead. 3.16. Look at the graph A to D carefully and state with reason which of these cannot possibly represent one-dimensional motion of a particle. Okay, so let's start with the first one. Okay, see when I see the first graph, okay, it does not represent one dimensional motion. The reason, okay, at one time a particle cannot be at two different positions. Let's take here at this time. What is the position of particle? There are two positions, one and two. Okay, clear? It's just logically clear that at a one time, no particle or no object or no person can be present at two different positions, right? So A does not represent one dimensional motion. Clear? The second, the graph is given of velocity versus time. Okay. See, similarly in B also, an object or a particle cannot have two different velocity at the same time. Right here also, if I will take this point, then it is having two different velocities. See here, this v1 and here v2, right? So see, an object cannot have two different velocity at the same time. At one time it can have only one velocity. So this also does not represent one dimensional motion. Okay, the third one, see, that is the graph of speed versus time. Now remember, speed is a scalar quantity, right? The value of speed will be always positive, right? You can see here this value in this portion, the value of speed is negative. This is 0 and this is less than 0 also at this time. Okay, these are all the values which have speed as negative, right? But speed is a scalar quantity and it cannot be or it cannot have a negative value. So this also does not represent a one dimensional motion. The last one, D. This is the graph of total path length versus time. Okay, now again path length, that is also a scalar quantity, right? Now path length can never decrease. Okay, it can only increase. Path length can never decrease. If it is at the same position, then the path length will remain constant. Okay, but here you can see that after this point, okay, after this point the path length is decreasing, right? Path length can never decrease. Just for example, if this is position A and this is position B, 10 meter. Okay, now if a person is traveling from A to B, the path length is 10 meter. Now again when he travel from B to A, at that time the path length will be 10 plus 10, that will be equal to 20 meter, right? If you move in this direction, then you need to add this. If you move in this opposite direction, then also need to add it. So path length can never decrease. with time. Okay, it will only increase or it can remain constant, right? So this is also not the graph of one dimensional motion. Okay, so none of these four represent one dimensional motion of a particle. Clear? Now let's move to the next one. 3.1a. Police van moving on a highway with a speed of 30 kilometers per hour fires a bullet at the thief car speeding away in the same direction with a speed of 192 kilometers per hour. Okay, if the muzzle speed of the bullet is 150 meter per second, with what speed does the bullet hit the thief's car? Okay, clear? Now see, let's take this as the police van. Okay, what is the speed of the police one? Okay, let's take police one. This is equal to 30 kilometer per hour. Okay, it's given in kilometer per hour, so let's convert it into meter per second. So we'll use our shortcut. 30 into 5 divided by 18. Okay, into 5 by 18, I got this is equal to 8.33 meter per second. Okay, let me write it down. 30 kilometer per hour, so this is equal to 8.33 meter per second. Okay, now see, uh, fires bullet a thief car speeding away in the same direction. Okay, so I will take this as thief's car. Let's say one is moving in this way. Thief's car is also moving in this way. Clear? So what is the velocity of thief's car? It's 192 kilometer per hour, right? So let's convert it to meter per second. 192 multiplied by 5 divided by 18. So this is equal to 53.33. So this is 192 kilometer per hour. So this is equal to 53.33 meter per second. Okay. Now, what is the speed of bullet? If fires the bullet, means obviously it will be the direction of the car, right? So now, what is the velocity of bullet? Okay, that is given 150 meter per second. Okay, now you have to find out with what speed does the bullet hit the thief's car, right? So what we'll use the relative velocity term. Now say the bullet is fired from a moving one. Okay, means the gun from which the bullet is fired that was already moving with 8.33 meter per second, and from that a bullet is emerging at 150 meter. Okay, it's my mistake, it's 150 meter per second. Okay, so what's the velocity? What is the velocity of bullet, okay, with respect to ground? Okay, that will be equal to v bg. That will be equal to, as both are moving in, it was already moving in 30 plus 150. So this will be, sorry, 8.33, and the bullet is fired in the same direction with 150. So what will the speed of bullet now? Velocity of bullet, it will be 150 plus 8.33, that is equal to 158.33 meter per second. This is the velocity of bullet with respect to ground. Here, now what is the velocity of this car? Now this is velocity of car with respect to ground, right? It is moving 192 km per hour or 53.33 meter per second with respect to ground. So now what is the relative velocity of bullet with respect to car? So it will hit by that speed. Okay, so what we need to find out? We need to find out the relative velocity of bullet with respect to thief's car. Yeah. So now see 53.33, this is with respect to ground. 158.3, this is with respect to ground. And both are in same direction. Here, so the relative velocity will be equal to bullet with respect to thief's car. Okay, we need to subtract 150.33 minus 53.33. Okay, the reason when this bullet had covered 150-meter ahead, the thief's car will be covering 53-meter ahead, right? So we need to subtract this much, okay, because it is when they are going in same direction, the relative velocity we need to subtract, okay. When they are moving in opposite direction, you need to add it. So this will be equal to 150.33, sorry, 158.33 minus 53.33. So this will be 105 meter per second. Clear? So the bullet will hit the thief's car with a speed of 105 meter per second. Okay, so I can write it down that the bullet will hit the thief's car with a speed of 105 meter per second. Clear? So this was about question number 3.18. So just note it down. Okay, students. So that's it for today. Thank you.